I'm happy to introduce Matteo Spadetto from the University of Leeds with Quantifier Completions of Doctrines. Thank you, Matteo.
Thank you so much, Ellie, for the introduction, and thanks to every one of the organizers for the possibility of talking during this series of seminars. As you said, today I'm going to talk about quantifier completions of doctrines, which comes from a joint work together with Davide Trotta, who is currently at the University of Pisa. And you can currently find the preprint of our joint work in archive called Quantifier Completions, Choice Principles and Applications. So today we will recall the notion of doctrine of posets, so that we can use it in order to introduce the notion of existential and universal doctrines. After that, we will present the following constructions, which are called existential completion of a given doctrine and universal completion of a given doctrine, discussing some properties, of course. And finally, we will see one of the main parts of our joint work, which is about preservation of logical structures. So say which logical properties are preserved by these completions under which hypothesis. Okay, let's get started. So I remind that a doctrine of posets is nothing but a functor from a contravariant functor from a category C with a finite product to the category of posets. The idea is that we think of P as a generalized version of the power set functor over the category of sets. So the functor sending any set to its power set and any function, any set theoretic function between the inverse image with respect to that given set theoretic arrow. So depending on the categorical property of such a doctrine P happens to model a given fragment of first order logic. For instance, I don't know, if P factors through the category of semilattices, then P happens to model the truth and the conjunction. This idea, this intuition is due to Lovier. For this reason, we call, so by thinking of the example that we are generalizing with this notion, for this reason we think we think of the functors Pf, where F is any arrow C. We call them pullback functors or even reindexing functors. We think of C as a category of context of a given type theory. So objects are thought of as context, and the arrows between them, arrows of C, are as usual morphisms between contexts, that is a list of terms. And so any object that is any context comes together with a set of predicates over that context. And the relation, the order relation, is thought of as the relation of syntactic provability with respect to the fragment of first order logic that P models. An example of doctrine is, of course, the subobject doctrine over a category C with finite limits. The functor sending any object to the poset of subobjects of that object, and any arrow between between two objects B and A to the pullback functor of subobjects along the arrow F itself. Okay, let's move on to the notion of existential doctrine. We say that a doctrine is existential if given if the following property holds. Whenever we have a projection, the pullback factor along the projection PR, which in this, when we talk about reindexing through projections, we also call them weakenings. So the property is the following: whenever we have a weakening along a given projection PR, we require it to have a left adjoint, which we call axis PR, and we require this family of left adjoints to satisfy the Beck-Chevalier condition. That is, whenever we have a pullback square, where the horizontal arrows are projections, we require this property, this equality, to be satisfied. Such a doctrine, as I said, is called existential, because if we think of the power set factor over the category of sets, so that we come back to classic Tarski's semantics, then the interpretation of the application of an existential quantifier can be precisely characterized by the fact that we are applying the left adjoints to the weakening factors. So this is why this is the right notion, this is the right property that you need in a doctrine in order to being able to interpret the existential quantifiers. We say the same thing for the universal doctrines, but in this case we require right adjoints because they correspond to the universal quantification through the same argument, say. And again, we require the Beck-Chevalier condition to be satisfied. So these are the notions of existential and universal doctrines. Having said so, we can move to the following construction. The notion of existential completion of a given doctrine. So suppose that we are given a doctrine P, we can build a new doctrine which we call Px. So given a context A, we need to define which are the new predicates in that context. So which is this new set Px of A. A typical new predicate of Px is a triple AB alpha, where A and B are objects of C, and alpha is a predicate in context A times B with respect of the doctrine that you start from. Now we need to give a relation of probability between predicates. We say that a predicate AB alpha proves a predicate AC beta when we have a term which we call F of C, such that this inequality holds, which basically says substitute the term F to the predicate beta, so that you get a predicate in the same context of alpha, and then you require that alpha proves beta. In this case, you say that AB alpha proves AC beta. Now we need to define how Px works over arrows of C. It is just the factor that takes such a predicate and sends it to the following one, where basically, again, we are substituting to gamma the arrow F. So which is the intuition motivating this notion? The idea is that we are allowing existential quantification in the free way over the predicates of P. So if alpha is a formula in context A times B, with this triple, we mean that we are existentially quantifying over the part of the context of alpha that is in the second component. If here I wrote A times B, comma 1, comma alpha, I would just mean alpha itself. But since I'm putting here the B part of the context of alpha in the second component, I am meaning the formula, there exists B such that alpha. So what is in the second component is what we are existentially quantifying by. Analogously, we can give the notion of universal completion of a doctrine of posets. The only difference is that is the order relation. The term that is re-indexed this time is alpha. Okay, let us see some results about these completions. The first one is that the universal completion only depends on the existential completion because of this natural isomorphism between doctrines. So if you start from, if you are given a doctrine, you only need to post-compose it with the functor from the category of posets to itself, then existentially complete this doctrine, and finally post-compose again with the opposite functor. As expected by the terminology, existential completions are existential doctrines and universal completions are universal doctrines. There's a notion of two categories of doctrines of posets. I will not go through the details. Maybe we can discuss it later. But this two category restricts to a category of existential doctrines and to a category of universal doctrines in such a way that the constructions that we have just seen extend to two left and two right adjoints, respectively, to the respective forgetful functors. Okay, this is interesting. Basically, there's a universal property of formulas which are free from the existential quantifier. And you can use this universal property in order to define existential quantifier free objects in the fibers of a given doctrine. It happens that an existential doctrine is an existential completion precisely when it has enough existential quantifier free objects, which means that any other predicate is the application of an existential quantifier, so of a left adjoint to a weakening functor, to an existential quantifier free object. And the dual property holds for universal completions. So I need to say that these results regarding the existential completion appear in previous works by Giuseppe Rosolini, Maria Emilia Maietti, and Davide Trotta. Through this result of Davide and I, we could find the corresponding statements for the universal completion. But this is very important to say that the results about the existential completion were already in previous works. For instance, this is a result contained in Davide Trotta's work in TAC 2020. This says that if you have a doctrine of posets and it factors through the category of inf-semilattices, that is, any fiber if is an inf-semilattice and any reindexing functor is a morphism of inf-semilattices, then the existential completion preserves this property. So the existential completion of P still factors through the category of inf-semilattices. By using our result, we can get the dual, the symmetric statement for the universal completion. So if you start from a doctrine which factors through sub-semilattices this time, then the universal completion preserves this property. So the P-un doctrine still factors through the category of sub-semilattices. This is the main part of the work of Davide and I. Study which properties, which logical properties are preserved by these completions. For instance, okay, let us see this definition. Doctrine of lattices. What is a doctrine of lattices? It is just a doctrine which factors through the category of lattices. So any wannabe power set is a lattice, and any re-indexing factor is a morphism of lattices for such a P. And we require C to be distributed in this case. Then the following result holds. Suppose that you have a lattice doctrine, and suppose the following property to hold.
Sorry, could I just ask a quick question?
Yes.
Did you mean the category of distributive lattices, or
no, just
okay, cool.
Yeah, sorry. Actually, we also studied distributive lattices, but in that case, preservation is not as easy as in this case. But anyway, maybe we can discuss it later.
Sure.
But
sorry for
in this
interrupting.
case, no problem at all. But yeah, in this case, I'm just talking about lattices without the request that they are meets and joins distribute. So suppose that we have a doctrine of lattices, and suppose the following property to hold. We require that re-indexings along injections have left adjoints satisfying Beck-Chevalier conditions for those pullbacks of injections which exist, because they do not in general exist, and which keep on being injections. This property is actually natural because it appears in many concrete cases. For instance, if you consider the subobject doctrine over l'extensive category, in this case, this condition is satisfied. Or if you consider the power set functor over sets, this condition is precisely a characterization of the fact that a subset of A, where A is any set, is also a subset of A disjoint union B for any B. So this condition is just an abstract way to require this for a given lattice doctrine. So I was saying, if this property holds, then the existential completion preserves the property of being a lattice doctrine. So the fibers of Px keep on being lattices. Then, if moreover the base category has points, which means any non-initial object of C has an arrow through the terminal object, then this condition, this property of having left adjoints to re-indexings along injections, satisfying BC condition, is preserved. So it's also enjoyed by the existential completion. Third, a technical condition that if under the same hypothesis, so C has points, if the injections, the re-indexings along injections have right adjoints, in this case, the existential condition keeps on enjoying this property. So these conditions 2 and 3 are actually very important because, as you maybe are expecting, we are going to apply the 2 completions sequentially. So the fact that these properties, because you see, the point 1 depends on the fact that the doctrine we start from has left adjoints along injections. So if this property vanished after a completion, then you couldn't apply the completion once more in order to have the lattice condition preserved. So these two points, 2 and 3, are very important because they allow us to apply the completions more times and still have the lattice property to be preserved. Okay, maybe we are running out of time, so I will avoid the proof, but yeah, maybe we can discuss it later. Through our result, as usual, we can deduce the dual statement for universal completion. So this time, if you start from a lattice doctrine and you require that you have right adjoints to re-indexings along injections, then the universal, so the dual property, then in this case, the universal completion keeps on being a lattice doctrine. And again, the two properties hold. In presence of points, both right and left adjoints to re-indexings along injections are preserved. So the universal completion keeps on having these left adjoints if the doctrine you start from has. Okay, now we need this result. We are almost done. This is a result which was actually proven by Pieter Hofstra, and in a more general, in a proof-relevant setting, so for fibrations, for Grothendieck fibrations, if the base category is Cartesian closed and the doctrine is universal, then the existential completion is not just existential, but it is also universal. In other words, the existential completion preserves the universal structure. And combining these results, we get the following main result, which says that if you start from a lattice doctrine such that the base category has points, and the base category is Cartesian closed, and you require that the injections have both left and right adjoints, the re-indexings along injections, and these families of right adjoints satisfy the Beck-Chevalier conditions for those pullbacks which exist and keep on being injections, then the following property holds, that the existential completion of the universal completion of P is a lattice doctrine. This is because of our results, and then it is existential because it is an existential completion, and it is universal because of Hofstra's result. And moreover, this property, the third point, keeps on being true because of our results. So the re-indexings along injections keep on having left and right adjoints, satisfying the Beck-Chevalier condition. Okay, I think we can stop here. This is these are some references, but you can find a more complete enumeration of references in the archive document. Thank you very much, and please, if you have any questions, feel free to ask.
Thank you. Please join me in applauding.